Toyota assembled a diverse group of engineers from Japan and also the US to evaluate and test our fuel cell prototype, which we will bring to market in 2015. So we did extreme testing, cold testing in Yellowknife, Canada, where we got temperatures down to minus 30 degrees, so really cold. Now we're doing the exact opposite. We're moving to the extreme hot desert environment where temperatures over 120 degrees. So we're here to evaluate all the extremes and understand this technology.
So the reason that we had the fuel cell vehicle in Yellowknife was to test the startup sequence and to make sure that we were able to start up quickly in really cold climates. Here it's more extreme in that the hot conditions can actually dry out the stack and we can have a loss of power while driving.
It's really important to put a fuel cell through these extreme environments because we get to test the software and the hardware at their limits.
So specifically as an engineer, I am here to focus on the customer evaluation in the North American market of the fuel cell vehicle. So to make sure that when we're climbing a steep grade and really hot temperatures and have the AC blasting, that we'll still have the performance that's required to get up the hill and even pass if necessary.
So we also tested in Death Valley, which, is one of the most extreme conditions on Earth. So we had temperatures up over 120 degrees Fahrenheit. So it's a challenge for any conventional vehicle. And so we evaluated a 1-hour soak just idling in a hot parking lot.
So we are doing heat soak here and check the fuel cell performance.
Does the system dry out? Does it stay in the correct operating temperatures and operating ranges for all the systems?
And now the vehicle is stopped right here, and the wind doesn't come into the vehicle, so the temperature easily go up high. So we are testing the idle status now.
Then we also went and tested in Las Vegas. Why test in Las Vegas? Of course, it's very hot, over 110 degrees. Then you also have lots of traffic jams, other things like that your customer normally faces. There's always some small condition that you didn't think about when you design it. And so it's important to go where customers go and to test where customers drive. And in Toyota, we call that Genshin Genbutsu, which means go and see. So we'll come to these locations that are remote, and we'll just test and see how the system works.
So a recurring theme with our testing is that we have to bring our hydrogen with us. So this is our Air Products mobile fueler that we have in Las Vegas to fuel the vehicle with hydrogen. So a lot of people, the general public, really is not familiar with hydrogen at all, and they have some real concerns about it. They hear compressed gas, they think Hindenburg, but really hydrogen has some great aspects to it, like how much lighter it is than air. So it's 16 times lighter than air, which lets it dissipate into the atmosphere much faster. Also, we use materials that are leak-proof or hydrogen-proof. They make sure that hydrogen cannot permeate through them and leak. So there are certain ways that the systems can be designed so that they're as safe or safer than gasoline systems. So when we first started filling vehicles, more than 10 years ago, it's been over a decade that we're filling vehicles, you used to see people out here filling with safety glasses and with PPE, personal protective equipment. They had the lab jackets on. We'd actually go out and ground the vehicle. Since then, we've been able to prove that there's no need to have all that extra safety equipment. Local fire departments are definitely becoming more comfortable with hydrogen, not only for stationary stations, but for mobile stations like this one. We've actually used this one in Vegas before, and this time the fire marshal didn't even come out because he's so used to it. So essentially in the fuel cell stack, for the protons to exchange across the membrane, it has to be humidified, which means we have to keep the fuel cell stack below 100 degrees Celsius, which is the boiling point of water.
Now, in a normal fuel cell system, you have a humidifier to take water that's within the exhaust and help feed it back into the input of the stack. And that helps keep a good humidity and water level within the fuel cell. But they're expensive. So a big challenge for us was to see if we could remove that humidifier and then operate the stack, and it can stay within those nice wet operating conditions that we need. And that's a huge challenge.
And we just created a new fuel cell stack that allows that water to kind of essentially cross-pollinate back over to the anode and humidify the entire thing internally instead of requiring an external humidifier to bring the water in. Yesterday was actually a really successful day for us. We were able to maintain speed, we were able to pass. We actually exceeded the performance targets that we had originally established for that trip.
So a typical testing day, we already have developed a plan of what we want to test and what we want to look for. So we go to our test location, for example, the Valley of Fire. We run our tests, and then we bring the data back to our hotel, usually a conference room. We process the data. Then we generate reports, and we can send that data back to TMC. And while we sleep at night, they can also look through the data. And then if we find any issues, we can work together to develop countermeasures and implement them for the next day's testing. Issues that may show up in the data points, for example, would be if our air compressor overheated climbing up Charleston Peak, because it has to work very hard because you're at high altitude. Or another one would be our fuel cell impedance, which is a measurement of the wetness or dryness within the fuel cell. The sedan prototype has been operating well. It's stayed within its operating limits. We're able to meet our design targets, and it can meet what we believe will be our customer expectations.